In Chapter 8, we're asked to find confidence intervals. So in this video, I'll talk about how to determine what type of confidence interval function to use in your calculator. The first thing you're going to do when you're working with a confidence interval problem is you're going to press Stat, and then you can press the left arrow once or the right arrow twice, whichever works better for you, and that takes you to the Tests menu. And from there, you're able to choose which calculator function to use. So these are our choices. The first one that we worked with in 8.1 was Z interval, and this is choice number 7 in the test list. Then in 8.2, we worked with T interval. And finally in 8.3, we worked with one prop Z interval. So how do we decide which of these three interval functions to use? So I'll take you through a little flow chart that helps you to determine what to use. The first thing that you'll ask yourself is this problem asking for a confidence interval for a mean or a proportion? Now, the easiest thing is if it's asking for a confidence interval about a proportion, because then immediately I choose A, which is one prop Z interval. And I just want to talk about this option a little bit. So this is pretty easy and straightforward. They're not asking for a whole lot of information once you choose one prop Z interval. They'll ask you for X and N. And X is the number of successes, and N is the number of trials. So one thing that you want to keep in mind is when you're working with one prop Z interval, and it's X, not X bar, but just a plain X, that X has to be less than N, because you can't succeed more than you try, right? That just makes sense. It actually could be equal to N, but it can't be any more than N. So X has to be less than or equal to N. And that's really important there. Usually when students come up during the test and say, I'm having difficulty with my calculator, something's gone wrong, and I look to see what they're doing, very often they have the X and the N values switched. So check for that, because that's something I can't help you with. So I can help you if the calculator is malfunctioning somehow, but if it's your error in how to enter it, then I can't help you. All right, so that takes care of proportion. But what if it's asking us for a confidence interval for a mean? Well, then I have a second question that I have to ask myself, which is, in this problem, do we know sigma or do we not know sigma? If we know sigma, then we're going to use number 7, which is Z interval. If we don't know sigma, then we're going to use number 8, which is T interval. And that's really all it comes down to. So in the book they talk a little bit about, well, what if you have more than 30 in the sample, or if you have less than 30 in the sample? They say more than 30 in the sample, you should use Z, and if you have less than 30, you should use T. But in reality, it really just matters whether you know sigma, yes or no. And that's the only thing we're going to really base our decision on. So, how do I know if I know sigma for the problem? Well, sigma, and here's the symbol for sigma. You can remember from back at the beginning of the semester that sigma is the population standard deviation. So whenever they say that sigma is equal to 4.1, I'm just making something up here, or if they say sigma is 4.1, or if they say the population standard deviation is 4.1. In all of those cases, that tells me that we know sigma, and in those cases I would use z-interval. Now, how do I know when I have a problem that I don't know sigma? It seems like it should be obvious, but this can actually be rather tricky. Let me take this out. Now, in every problem, whether it's about a mean or a proportion, there's always a sample being taken. And you're going to be given the sample mean if it's a problem about a mean. And if we don't know sigma, they'll tell you the sample standard deviation. So we have the sample mean and the sample standard deviation. If we have those two things, then we definitely want to use t-interval. So how do I know that they are giving me the sample standard deviation? Well, it might say, literally, sample standard deviation equals 2.7. I'm just making that number up. It could be anything. Or they could write S equals 2.7 because S is the symbol for the sample standard deviation. Now, a third thing that comes up, and this is the one that's really the most tricky. Let's see if I can fit it in here. So you might have a sentence in your problem that says, of 19 people surveyed, the sample, I don't want to say that. Let's see. The mean was 50 and the standard deviation was 4. So in this problem, what do I know? Well, I know that they said standard deviation here. But where did that standard deviation come from? It came from 19 people surveyed. What do we call this? That's called a sample. So, and very often it'll say out of a sample of 19 people. So it might literally say that, or it might just be referencing that we're surveying 19 people, so that's my sample. So since the mean and the standard deviation are in the same sentence, that's where they came from, was this sample. So that's a sample mean and a sample standard deviation. So we know that since we have the sample standard deviation, they're not going to give me the population standard deviation, and so again I should use t-interval in that situation. So that's how we decide. Do we know sigma? Do we not know sigma? Or is the problem about a proportion? And that tells me what to use, if it's z-interval, t-interval, or one prop z-interval.